understand, because now, first thing first, I'm going to train you how to study. Understand? Right. So if I look at this, we're going to focus on mechanics, Newton's law. Ne? Can you see? Right. So you need to understand how to define Newton's law. And when I write down the Newton's law, I'm not gonna write it down, but I'll train you how to define it without by using the equation. Eh? Okay, so now let's start with, if we have an object that is on the horizontal, we're going to start with horizontal forces. Let's say I have an object like this, and this object is on the horizontal surface. If I look at this, okay, so this is my horizontal surface, and I have an object that is on horizontal surface. Like, tell me how many forces are acting on this object. So we're going to call this maybe block M. How many forces are acting on this object?
Two.
Which is?
The block on the surface on the block.
The block on the surface on the block. Okay, if you say it like that, I think I can take that answer. Eh? But what are those forces? What do we call those forces? Okay, we have a normal force and the Fg, which is the force of gravity. So any object that is in contact with the surface, it will experience what? The normal force acting up. So the normal force, it's always perpendicular to the surface. You understand? Look at this laptop. It's in contact with the surface. It's experiencing a normal force, and then also it will have what? The Fg, which always act downward. Now tell me, why is this table not falling? I have that laptop on top of the table. Why is not breaking the table? If maybe I take that big table, or if I take this and put it on top of the table, what will happen?
It's gonna fall.
But now there's a laptop on top. Why is the laptop not breaking the table? You see, when you do physics, you need to understand what is going on. Then, like, love the subject, understand? So now, look at this. The reason the table is not falling is because the table, it exerts an equal normal force as the weight of the laptop. You understand? So this tells you that the normal force is equal to what? To the weight. You understand? Okay. So now look at this. I'm going to apply a force, and we're going to call this F applied. You see? So how does the applied force affect the normal force and the weight? Doesn't affect the normal force and the weight. It doesn't change anything. The normal force is still equals to Fg. You understand that part? All good. Okay. Now, the moment that this object starts moving, it's going to experience what? Exactly, the frictional force. And where is the frictional force going?
To the left.
The left, in an opposite direction. So this will be my Fk. Okay. So now in an exam, the first question, which is question 1, the first question, so I'm going to call this A. So the first question, they'll want you to define, in most cases, they want you to define Newton's law, first law, second law, you understand? Then number B, they'll ask you to draw a free body diagram. Okay, so now it's like we are creating what we call a cheat sheet. Already I know in an exam, June exam, they'll ask you to draw a free body diagram. We're talking about 2 marks plus 4 marks. You understand? So far, 6 marks. Trust me, you don't want to give away these marks. You can't just donate this easy mark. So now let's talk about drawing a free body diagram. So now I need you to listen to this one very carefully. Now. When they ask you to draw a free body diagram, you, sorry, you look at the mark allocation, okay? The mark allocation, it will tell you how many, you know what I'm going to do. Since we don't have much time, how many days left before exam? 30 days. Today is 16.
Um, my first paper is in 2 weeks.
No, for physics.
Oh, for physics.
You said 12 May, that's in less than 30 days. So we don't have much time. So at the same time, we'll be working on past papers. I'm going to open a past paper so that you can see what I'm talking about, right? Let me just, okay. So now I'm going to show you, now that you know how to draw a free body diagram, let's quickly just work on drawing a free body diagram first. Right? That's what we're going to start with now. So we'll be looking at different objects and we'll be drawing free body diagrams on different objects. Yeah? So let's start with this one. This will be the first one. So on the first one, I'm not sure if you can see. Can you see?
It's a bit light.
Okay, let me try white. Yeah? Okay, for the first one, if I want to draw a free body diagram, this will be my free body diagram. I'll have the applied force going in that direction, right? And then I'm going to have the frictional force, which is Fk, going that direction. Then I'm going to have the weight, which is Fg. Then I'm going to have the normal force. Are you happy with that? Okay. Number 2. Okay, so now I'm going to change something. Yeah? Let's say that I have a block, the very same block mass M, and it is on the horizontal surface. Okay, so now what I'm going to do is that I'm going to change and apply the applied force at an angle theta. Understand? Okay, then I need you to also draw a free body diagram, know how to draw the free body diagram when the force is pushed at an angle like this. When the force is pushed. So, you see, right. It is pushed. There's a difference where the force is pulled and when the force is pushed. Okay. Let's start with number 2. I'm going to draw a free body diagram for number 2. For this one, you indicate all the forces that are going on that. So we have an applied force moving in that direction. Understand? Because it applied at an angle. Then we know that there's always weight, which is the Fg, and there's always normal force, which is in an opposite direction of the Fg. So, sorry. So the normal force, it always goes in an opposite direction as the Fg. Understand? Right. So now there's one force missing. There's one force missing there, which is the frictional force. Look at the arrow. Where is this going? Yes. So that is going to the right. The frictional force will go to the left. So this will be my Fk. Understand? All good. Okay. So I'm trying to teach you according to, I think you don't have to stress about taking notes. I'm going to send you all these things. All right. So now when I look at this diagram, uh, there is that one force that is missing. I'm not going to include this and I'll explain why. Now let's move to the next one. So look at the arrow here. You see, when I draw a free body diagram for number 3, it is going to move like this. We're going to say, look at where is the F applied going this time. See? Can you see where is the applied force going? Look at this. Is this making sense for you?
It is.
Or are you confused?
This is the pulled one. It's making sense.
That's it. So now, if Kilwell Lowry for applied force, he go fast, where is the weight going? Weight Tiliona is going down again. So this will be my FG. Okay. So the normal force always in an opposite as the FG. Now I need you to tell me where's the friction going?
The opposite direction.
Oh, okay, where is this object going?
I want to see it downwards the other way.
Will it go down pedal? Okay. Look at this. Look at this book. I'm pushing it at an applied angle. Is this going down? It's not going down. But I'm pushing the object at an angle. You see, there's a difference pushing like this and also, you see, at an angle. But it's not going down. So what is that telling you? That this force will go to the left. You understand? It will move this box, it will move in that direction. So if it moves in that direction, where is friction going? Exactly. This, this is what you need to understand. And if you don't understand this, it's best that you over-underestimate because you're going to need this to do your calculation. So the frictional force will go in that direction. This will be my FK. Okay. Understand? Okay. So now there's this something that is very important. I want to add now. Ne? Okay, we did for when the force is pulled at an angle, when the force is pulled at an angle. Before we go to incline, there are some of the things that I need to indicate now. Ne? So if an object it's pulled, so this one we say that it's pulled at an angle and this one is pushed. Okay, so if an object is pulled at an angle, there is this will have a vertical component that will reduce the weight. And if you miss that, there's no way you'll get the calculations correct. I understand. So now, for you to understand this, you need to understand what we call head-to-head method or what. But now, I'm going to give you a way that you can claim this. Né? Look at this arrow. I wanted this arrow here. The vertical component, né? You see this F applied. We need to resolve it into components, meaning that we're going to have the Fx going in that direction, and then we're going to have the Fy going up. You understand? Okay. This one, the Fx, it goes in that direction. This is your Fx, and then the Fy goes down. This is the Fy. So now, if you look at this neck, I need you to look at the most important part, which are the arrows. Look at this. These two arrows. And then look at this. These two arrows. Understand? So if the force is pulled at an angle, the area Fy, it will be in contact with the applied force. And if the force is pushed at an angle, the area Fx is the one that is in contact with the F applied. Then now you're going to understand why this, you need to understand this to make to do calculations. Né? Okay, so when you work with Newton's law, you need to understand how to calculate the normal force, which is where the Fy comes in. Understand? So let me go back up and then look at this. We said that the normal force Fg, if the force is on horizontal surface and if the force applied is horizontal to the surface, Understand? So now when I look at this, I'm going to say that uh, for this one, to find the normal force, you'll have to draw a free body diagram. Yeah? Okay. Now, I already know that the normal force is going to be equals to Fg minus Fy. Yeah? The normal force for this one is going to be Fg plus Fy. Alright. So I'm in an exam, I don't have time to. So now, if you can know these two formulas, you are good to go. But it's very important that I explain where are these two formulas coming from. Now, tell me, what is F1? Because now when I'm the one like doing too much talking. Now it's your time to shine. What is Fy?
It's the angle.
It's the angle. No, not really. Fy is a vertical component. Ne? This takes you back to maths. You do pure maths. Okay. Come maths, ne? Come maths. If you have a triangle like this, again, this is your what? This is your Fy again. And then let me write it down here. This is your Fy. And then we said Fx goes in that direction. This is your Fx again. This is theta. Look at this. They form a 90 degrees. This is a right angle triangle. Again. So if it's a right angle triangle, we use the saw cut tool. I understand. To find Fy and Fx. Again. So what I'm going to do, Korkitori, I have, look at this, I have the F applied, which is something that is given. Again, the F applied will be given. This F applied, it will be given. And then I'm going to look for what? I'm going to look for Kinale F applied, which is my hypotenuse. Again, this is my opposite. This is my adjacent. Tell me, do you understand why Kinale opposite and adjacent? Are you familiar with right angle triangle? Remember, the side that is opposite to this angle, revision to opposite, again. And then if this is opposite, the 90 degrees is formed by opposite and adjacent. So I'm looking for Fy, I'm given Fa. So I'm looking for opposite and I have hypotenuse. Do I understand? You're going to use the sine of that angle, which is the sine of theta. It's equals to, what's your opposite? Kfy. Again. And what's your hypotenuse? Kf applied. Again. Then I'm going to make Fy subject of the formula by multiplying this side by Fa, multiplying the other side by Fa. Therefore, what is Fy equals to? We have Fa, the sine of theta. So this is Fy. So more than Fy, Ototia applied force while multiply the sine of that angle. You get it? Then you do the same to find the cos, the Fx, which is the horizontal component. Again, so the horizontal component is over. I I have adjacent again and hypotenuse. Adjacent and hypotenuse. So it over the cos theta it's equals to then your Fx. Okay, it's adjacent, which is your Fx over Fa. You're going to multiply both sides by Fa, multiply both sides by Fa. Therefore, what is the Fx equals to? It's Fa, the cos of theta. Right? So, when you don't have to stress, Kaore, you don't have to stress about doing all this, going all the trouble. When I just know that Fy, it's Fa sine theta, Fx, it's Fa, the cos of theta. Is both. Both of them did Fa. the difference go sine cos. Then tutoring. Oh, Fy kionaya sine. Fa, I mean Fx kionaya cos. You think we're going to this thing? Okay. So now, if we're now you're saying, or you're not going to forget this, let me take you back. So this tells you that therefore your normal force Fg came mass times the gravitation again. So your normal force over mg again minus fy came.
Same.
So you have fa the sine theta. So que formula ya normal force? If the force is applied at an angle, is pulled at an angle again, and then now therefore the normal force it's equals to mg, we add fy, and we said fy king f applied and sine. Yep. So now do you want me to explain where is this formula coming from? Okay, so I'm not sure because I just want you to be able to study this notes on your own. So I'm not gonna put everything there. Let's start something new here. So look at this. Let's start with again, this is my box. And we said the force is applied at an angle. This will give us our fx again. And then the fy goes up again. And this is theta. Right? So, this is theta. So you're going to draw a free body diagram indicating all the vertical forces. Again, but I have normal force going up again. We have what? The Fg going down. Then now we have Fy. Fy up. So this is your Fy. I understand.
I must throw two arrows. I must throw two arrows going.
Yes. You know why we have two of them going up? Boy, again, there's the normal force going up. There's the Fg going down. There's the Fy going up. So Fy, it's a vertical force on this object. I understand. All draw a free body diagram, we indicate all the forces. Like now, I'm drawing a free body diagram for forces that are vertical on this. Then can you draw from same point? Then FG first, FY, FN, they are coding. Okay? Then F net, since this thing is a vertical, F net is 0, the acceleration is 0. Right? F net is add all these forces. But when you add all the forces, you pay attention on the direction. So you choose direction, you're going to take up as positive again. What about all the forces that are going up? They want. But I take up as positive. All the forces that are going up will be positive. Exactly. So anywhere positive, this will be Fn. We added this with Fy. Then if up is positive, all the forces that are going down will be negative. So we're going to subtract Fg. It's equals to 0. Over not killing. But F net, it's equal to 0. Again. So now we're going to say up as positive. So or either the first young podium was subtracted young of us because you said the direction is up as positive. Are you happy with that? Let's make Fn subject of the formula. But Fn is equals to what happens to Fg rate at this side? Exactly. So Fn is Fg. Then what happens to Fy rate at that side? Negative. Then minus Fy. So now I think you understand where is that formula coming from. Look at this. Well, okay. Remember, this was when the force is pulled at angle. Again, so Rodira, the force is pushed at an angle. Okay. Pushed at an angle. So I have a free body diagram. Okay, it works like this. Then when I know the force is pushed, remember we said the fx will go that side again. Fy goes down. So this is my fx, this is my fy, and then this is my f applied. Again, okay. So now we need to draw a free body diagram indicating all the forces that are acting on that guy. Normal force always up. Again, Fg always down. Now we have Fy going down. I said indicate what? The vertical forces fell. So this will be F net. It's equal to 0. Then I'm going to choose direction. Net. So I'm going to say up as positive. If I take up as positive, what are you going to do now?
Don't take over the top parts and substitute them by the F net.
Okay. Take them how?
Fn.
Okay, Fn. Again, we said up as positive. Remember, Kamu, we said if up is positive, all the forces that are going up, we add them, then we subtract all the forces that are going down. You do the same this side. Draw a free body diagram. You have Fn going up, then you have Fg going down, and then you have Fy going down. Then up as positive means that we take Fn, which is the one that is going up again. Then you subtract all the forces that are going down. Then let's equate these two. 0. So what happens to Fg when it goes that side?
Positive.
And what happens to Fy when it goes that side? Therefore, what is your Fn? It's going to be Fg plus Fy. And now you understand where is the second formula coming from again? This one. Yo, I'm just afraid to add more information, man. Because there's still something that you need to understand when it comes to this thing, man. So I guess today we only work on horizontal. Then when I come back, I'm gonna take you on incline. You understand? Eh? Yeah. So now you see all this information. I know what this is too much again. But now this is not really like too much. Well, when I just know this formula of normal force, Kmg minus Fa, the sine of theta, if the force is applied at an angle, it's pulled again. And then if the force is pushed, just know this formula, then you're good to go. But only two formulas to calculate a normal force, then know how to draw the free body target. For now, this is what I need from you. Two formulas. Again, now I'm just showing you where is this coming from. Don't focus on that. When I focus on this one, oh, Fn, if it's both, if again it's Fg minus Fy, if the force is pulled, and then if it's pushed with the opposite, instead of Fg minus y, you add them. You see, you add the two. Do you guys do like prepared speech? That's good.
Sometimes.
Sometimes. And how do you prepare for your speech?
Sometimes.
You read it 10 times, 100 times. When I give you the documents, I'm not sure if you have a laptop, you just open this thing there, you just dance around this place. Oh, if the force is pulled, I add Fg, I subtract Fy. If the force is pushed at an angle, like you see, you until your mind, until this thing stays in your mind. You understand? So now you do a prepared speech again. You read it 10 times until it stays in your mind. Then tomorrow you go to school, you're going to do your speech without even looking at the paper. That's how you should also do physics. Some of the things they just want you to look at them like multiple times until they stick in your mind. And now, remember, I'm not only here like to teach you these things because I also need to train you how to study. And I don't like learners telling what they study smart. I mean hard. I need you to study smart, not hard. You know what? Someone can just study maybe 10 days. When I study only 1 day and you study smart ka 1 day, all I are doing more booking hours and hours for 10 days. When an exam major, when the person who did them for 1 day, you even get like way high marks than the person I learned 10 days. You study smart, you study with a goal. And when you say you study, just don't say, I'm going to do physics today. That's where's your study table? What thing? Study table. You have it. I wanna see it. Like is it on the wall? Like
It's still on paper.
yeah, I wanna see it because I know what I'm looking for. I'm not going to get on your study. Hmm?
I made two separate ones for to help me with chores.
Hmm?
This is it's an it's an
No dishes.
the week I don't have this.
Oh, okay. Okay. So okay, I understand how the study table goes now. One thing missing. Well, I'm recording. Class 17 to 1745 will do maths. Theory textbook, chapter, YouTube. Always have a question for your teacher the next day. Yeah? One thing missing. If you want to work this nice, yeah? We're going to say maths. Then I'm going to do, you state a goal on your study. You understand? You set a goal and be like, you know what? I'm going to study maths and I'll do functions. On functions, I'll focus on hyperbola and I'll spend 30 minutes on hyperbola. Then the remaining 15 minutes I'll do a past paper. You understand? That's what we call you have a study with a goal. You study with a goal. When you say chapter, you don't even know what you're going to study that time. All right. So this tells you need to create this every week and say Monday I'll do this topic, and next week you understand. Yeah. So I want us to just take one example and then let's work on that example. And I'm gonna take one example. You see, but I explained this. I've already explained everything here. Hmm? But look at this. You know how to draw a three-body diagram. Again, sharp. And then still a three-body diagram. Now they are telling you that Fn is Fg. What? Fg is equal to Fn, which is this one. What we started with. All right? That one. Then now all this Fn is Fg minus F1. If the force is pulled and an angle. If the force is pushed, Fn is it? All this. Now we understand all this. Okay. We'll do incline. Eh? I don't want to add incline yet because we don't have much time. We're going to use the remaining time to work on these examples. Again, okay. Let's do examples. I even forgot to tell you how I conduct my tutoring sessions, but it's fine. I'll definitely tell you by the time we end the this. This is one of the part most of my students they don't like. Understand? Yeah. So if I have, you see, you're going to answer all these questions, right? This question, that question, let's quickly work on that. So we have a crate with a mass. This is example. Why time moves faster, so especially when you have to do something. Okay, so now if I have a block that is on horizontal surface, okay, and then uh, they say that a crate with mass 20 kg, this is 20 kg, and then they say that it is pulled from rest across a horizontal rough surface with a force of 100 newtons. So we apply a force that is F, it's equal to 100 newtons, né? And then the frictional between the crate and the force, you are given the frictional force which goes in that direction. I don't understand why this thing keeps on. So this is my FK, né? Right. And then what's next? Calculate the acceleration of the crate. That's question one. Calculate the acceleration. The acceleration. Okay. So when they say calculate the acceleration, you know what you're going to do. You need to include, you need to draw a free body diagram. Acceleration, it's what we call a horizontal force, né? Okay? Not exactly a horizontal force, but in order for you to calculate acceleration, I'll show you. We use F net, it's equal to ma. This is Newton second law, né? Sharp. So first thing first, you need to draw a free body diagram indicating what? All the forces that are acting on the object. The horizontal forces. I need you to say this after me. F net, I'm going to add only the horizontal forces.
I'm only adding horizontal forces.
Yes. So it depends on what you are calculating. Yeah? So say that if this has to do with Newton's second law, I will only add the horizontal force, and this will make sense. Let's draw the free body diagram. When you draw the free body diagram, we're going to indicate the forces that are on that object, which is the F applied, and then we have the Fk. So they said that the Fk is what? The Fk is given as 12 newtons. Yeah? Okay? So now, looking at this, you need to choose direction. So I'm going to take the direction of the motion as positive. So this is going to the right. Right? So I'll take right as positive. Again, right. So now we need to calculate the acceleration. You're going to take the forces that are going to the right, you subtract the forces that are going to the left. Equate this to MA. Is this easy for you? You take the force applied, which is 100, you subtract the kinetic friction, which is 12, equate this to the mass, which is 20, times the acceleration. Right? What? 1200 minus 12, I think that's 88. Okay, so this will be 88. It's equals to 28. Okay? And then now we are looking for acceleration. I'm going to divide both sides by 20, divide both sides by 20. Therefore, what is acceleration? You just have to punch that on the calculator and see what you get. So what is 88 over 20? Do you have a calculator?
24. Hey.
It's 4.4. We have 4.4 here. 2 goes into 8 4 times.
Okay.
4.4 net. So this will be 4.4 meters per second squared. Acceleration, it's in meters per second squared. Then look at this. Is your answer positive or negative?
Positive.
Positive. We set right as positive. So if your answer is positive, then the acceleration is going right. Are you happy with that? I understand. All good, right? Okay. So now let me change the question. Understand? So let's say they want you to calculate the weight. This one is going to be a very easy question. Then we'll keep adding one more questions. Then let's say they want you to calculate the weight, which is FG. Né? Remember, you draw the weight, it's a vertical component. Okay? You're going to draw the vertical forces, which is the normal force and what? And the FG. There are only two forces. F net is equals to MA. Understand? And then if F net is equals to MA, then I'm going to like choose direction. Let's take up as positive because this is up and down. So if it's up as positive, since this is vertical forces, the acceleration is 0, which makes F net to be 0. Understand? So I set up as positive. I'm going to take the normal force. I subtract the FG, equate this to 0. So this is F net. It's equal to F. Already you know this. We discussed this when we started the lesson. So therefore, what is your Fn? It's just mg. And you do the substitution. The mass is 20. G it's 9.8. So you just have to multiply the two and get the answer. Right? What is that equals to?
196.
196. 96 newtons. No, I'm sorry. Yeah, newtons. That's the weight. Oh, we are calculating not the weight, man. We are calculating the weight. Normal force is equals to the weight, or you can say, oh, let's say this is normal force. Let me indicate this. What we are doing now is normal force, which is equal to the weight. So this is Fn, the normal force. Okay, so now to find the weight, you just say Fg is equal to mg. Then the mass, which is 20 times 9.8, you'll get that 196 newtons. Okay, is the weight in newtons or in kg?
I think it's Newton.
Oh, okay. Let's move to the next one. Now, let's take everything that I showed you. We are now applying this on the examples. So I'm going to take this object, which is something that you should expect in an exam. So we have a force that is applied at an angle. So this is your F applied. And then they say that a crate with mass of 20 kg, it is pulled from rest on a rough horizontal surface at 100 newtons. So the F applied is 100 newtons and it is pulled at an angle theta. And then the angle theta is given as 30 degrees. And what else do we know? Calculate the acceleration of the crate. So the frictional force which will go in that direction, your Fk, it's given as 12 newtons. Now they want you to calculate. They want you to calculate what? Acceleration. Why am I struggling to write the word acceleration? Okay. Look at this. Look at what we did on this one. I said when you do acceleration, you add what?
Horizontal.
Thank you. Only the horizontal forces. So now this tells you that you'll go on your diagram, indicate what? The horizontal forces. I said if the force is pulled, Fx will go in that direction. This is your Fx. And this is your Fk. So when you draw the free body diagram, for the horizontal forces, you'll have Fx and what? The Fk. And now I remember this learner that asked me what I say. Why don't we include the applied force when we draw? Like, it's not applied force affecting axle. Oh, the applied force, né, it is like by changing it into a component. Again, when we find fx, do you still remember what is fx? Or say popular fx, okay. Do you still remember what is fx? Try to popular Roberts.
When you say FI is a vertical component, so FX is a horizontal component.
But what is the formula for fx? Try to remember the formula.
FX equals if I know it's cos theta.
See, it's cos theta times 1. Exactly. Look, so you know what you need to do. We thought, oh, this is my diagram, this is my fy net. And then, just in case if you forget, net, according to SOCA2, so this tells me that I have fx, which is my adjancent, right?
Mm-hmm.
And then I have this as my hypotenuse. So this tells me that fx will be my adjancent, which is the applied force. Fx is cos. Look at this. Or just say Fx is cos times applied force. So your Fx is equal to F applied the cos of theta. Are you happy with that? Okay. Then you choose direction again. Whatever this thing, it's pulled at an angle again, but the object won't go like up, or it will go to the right. I'll take right as positive. I understand. So if we take right as positive, then what are we going to do? We take all the forces that are going to the right, we subtract all the forces that are going to the left. I'm looking at this free body diagram. Then I'm going to equate this to what? The MA. Right? What? So remember, F net means that you add the forces, the horizontal forces, you equate this to MA. Still with me? Nice. So now, what is your fx? It's f a, the cos of theta, minus fk, it's equal to ma. So you just have to substitute. Applied force is given as 100. You multiply that by the cos of theta, which is given as 30. Again, you minus friction. What is friction? Exactly. We're going to minus 12, equate this to the mass, which is 20 times acceleration. So I need you to put this on the calculator. Tell me what you get.
86,60.
You got
86,60.
86,60. So 86,60 there, it's equal to 20 times 8. What I need you to do, say answer divided by 20 on your calculator. Answer. Because we don't want to run off again. Say answer divided by 20. What do you get?
4,33.
4,33 meters per second, and that's my Q to I just want to. So remember, I talked about, like, I think